Welcome, guys, to week 8. The course has gone by very quickly. Feels like just the other day we started and we had the first week. Hopefully, you guys have learned a lot and gotten your hands kind of involved with Ruby on Rails. I'm going to talk about a review and then also just what comes next after this. So, first, let's cover a review. So, week 1. Who remembers what we covered week 1?
HTML.
Yeah, we had some HTML.
Routing and controllers. Oh,
So we'll say basic routing, controllers, a little bit of models too, right? In other words, try to do some MVC. Right? Remember week 1 we did the coder restaurant? You guys remember that one? So we did some, I guess, basic JavaScript, HTML, working with Google Maps. By that here. All right, week 2. Who remembers what we covered week 2? Does anyone remember week 2? Authentication. User authentication from scratch, right? We didn't use any gems. So what did that look like? Remember we had the has secure password. Right? You guys remember has secure password? You add that to the active record model, and then it uses what? But it doesn't use password field. Remember what the field has to be called? Remember the name of the field? Exactly. Password digest, right? So you have the password digest in the database table, right? And you instead, right? And then you would ask for the user. So remember how we had strong parameters as well. So then you would ask for, oops, let me try to format this. Right. Remember params dot require, and we can say like the user model, and we permit certain fields, right? So we permit like a name field, and if we're using has secure password, we don't want to pass in a password digest, or do we? We don't, right? We want to pass in the password and maybe password confirmation if we're using confirmation, right? So this is basically asking us on the parameter side, when the controller gets the parameters, which ones are we going to allow through? And that was called strong parameters, that you're whitelisting, right, the parameters you pass through, so the controller doesn't just accept anything, it only accepts certain things. We're passing in the password and password confirmation because you set those on the user model, and has secure password knows then to generate a digest from the password field, and it stores that in the password digest. One thing we're missing though is we had to use a gem. Remember what gem we used?
device.
Not devise. We use a gem for encryption. Yeah, there you go. Bcrypt. I don't know how to spell. Bcrypt. Right, so that handled the encryption for us. We didn't have to actually deal with encryption. If we had the digest, it would take the password, convert that to a digest, put it back. Good. So we had strong parameters. How else do we store the user? Once the user logged in, right? And you remember how we stored the user, kept track of who the user was? Session, exactly. Nice job, Kung. So we had session to keep track of the user. And during the lab, some of us also got to using like third-party authentication. So logging in with Facebook. Remember Facebook login? Trying to use OAuth. That's for stuff. Great. All right. Week 3. Who remembers what happened week 3? What do we cover? Testing. Exactly. So we started off with testing philosophies, right? The importance of testing, that any application needs tests, because over time, if you want to change things, how do you know if it's going to work? Well, you don't unless you have testing, right? And the testing really lets you know. Guys, don't worry about the projects yet. You can work on those later. The testing really lets you know that your application actually works. It says what it does. If someone comes in later and changes, or let's say you have a bad Git merge, how do you actually ensure that the application still works? You have a bunch of tests. So that's why testing is important. It's always easy to cut corners with testing and to say, oh, well, we'll just build the application, we'll push it out, or my boss gave me this demand, he wants it done in 2 weeks. I'll just build it, deploy it, and we'll add in tests later. But then you never really get back to adding tests because after you deploy it, there's always a new demand. Someone else always says, oh, now that you did that in 2 weeks, do this else, something else in 2 weeks. And so you really can't cut corners with testing. It's one thing to say, oh, I'll come back and add tests later, but that's usually easier to say and actually harder to do. So it's important that you incorporate testing into your workflow, whether that's test-driven development, right, which when you write the test first and then the code, or maybe you write the code first and then the test. But as long as you're doing it at the same time, that's the most important part, so that you're keeping yourself fresh. You remember what the code's actually doing, and you're not actually cutting corners. So first we covered some mini tests, and that kind of looked like, right, like assert equal, oops, right? So you'd call assert equal, and you'd say, expect, maybe the response dot body to equal my event or something, right? Or maybe you were to just compare array, so we're going to say, some array to set. And when it comes to assert equal, remember the first thing was the expected, so maybe we'll say, 1, 2, 3 or something, right? And this way we're just comparing the collection, we're comparing the elements in the array as opposed to the actual order, if the order doesn't really matter. If the order does matter, we would just compare them as is. And you can add in an optional statement, or, some array not equal, right, for when things go wrong. And then we mainly focused on RSpec, which was our testing framework. And remember how RSpec was a little different? It wasn't quite just assert equal, but it was expect something to, so expect some array to equal, and then, you have your thing, so 1, 2, 3. Right, so RSpec kind of read a little bit more like an expectation and less like coding. So rather than just saying assert equal, it was expect something to equal something else. And that way it's a little clearer as to what you're actually comparing, right? And there are a lot of helpers, and so RSpec provides many helpers, so you can say expect something to equal. The documentation, let's see, so it should be true. Controller specs. Let's see, controller specs, pull them up. So you can check to see if an instance of a controller. So it provides a lot of different ways to compare things. You don't have to just always say is equal, expect something to equal. You can say expect it to be an instance of, expect it to return maybe status 200, expect it to route me to a certain action, right? These are all things that RSpec provides. It's a pretty rich framework. In addition, it's also good to add in some code coverage. So we talked about adding in code coverage. This is just a good way to see, are my tests actually working? Are they actually testing my code, or am I only testing certain parts of it? It's good to see, what areas of my application are lacking code. So maybe you wrote some tests, you feel pretty confident, but you look at the code coverage is only about 40%. That means that you still have some work to do. You still really, haven't given yourself a complete testing package. So it's just a nice way to kind of find out the holes in your testing as well. So maybe you think you've written some good tests, it covers a lot of it, but then you run your code coverage and you realize that there's an entire method or function that hasn't been tested. Code coverage is a good way to identify what parts are really needing some tests, and you can go from there. One thing that a lot of companies will do is they'll add in code coverage metrics. so like a percentage of the total code that's been tested. And the rule is you cannot commit code that takes that percentage down. So let's say a company has a repository, it's at 60% code coverage, it's pretty good. If you add in some new code, the rule is you can't let that number drop. You have to at least maintain 60%, which means you have to write more tests because you're adding in more code. A lot of times it's better to even go 60 to 61%, right? Add in some more tests. So that's one way that a lot of projects use code coverage to enforce writing tests. If your code coverage number drops, you can't merge it in, you got to increase it. And that usually means you got to write some more tests. It also could mean you could just delete old code. That works too. If you're deleting the amount of code that is not needed, that's useful. But usually it means you write more tests. Great. We also talked a little bit about continuous integration. Exactly. You guys remember what this was? Right. This was setting it up so that when you create a pull request or when you commit, you automatically run your suite of tests and get some results. And GitHub has a cool. I don't know if you guys have seen this. They are really encouraging now, like a lot of these continuous integration. So let me see if I go to like a pull request. For my repositories here, it looks like it'll ask here, set up continuous integration, and you can say explore, and it'll essentially help you walk through setting up continuous integration with your GitHub repository. So it gives you, links to all the different CI tools that integrate with GitHub. I think with just a few buttons, you can click set up an account and run your test whenever you create a pull request. That's very useful. So let's say you have a repository, someone wants to create a pull request on it. Fantastic. How do you know it works? Well, you could ask them to run the test. They could say, great, test pass, but you don't maybe trust them. Maybe you don't know them. Maybe you run the test yourself, but that could take more time. So you set up continuous integration, bam, open up a pull request, and the tests are all run, and you get an instant response. Did it work or did it not? And that just speeds up the development cycle so that you can start to get information back right away if the pull request is actually going to work or not. Great, so that was mainly week 3. Basically all sorts of testing, and the lab was that as well. So let's go on to week 4. What did we cover week 4? Exactly. JavaScript and Ajax. We talked a lot about JavaScript in the browser, so how to run for the console and using JavaScript. So maybe on document load. If you're using TurboLinks, you also have to use on TurboLinks load. Creating an event and then using Ajax. So for example, we said remote true, right? So adding that to your form 4. Something like that, right? So now all of a sudden the request is no longer synchronous. It's not going to wait for a response back, but it'll instead just send the response, and the server can respond whenever it's done. We also talked about different sort of responses. So responding with HTML, JavaScript, and JSON. So remember how we did format, do, and we can say, I believe it was format dot HTML, right? And you could essentially respond to different types of requests. So you can respond to HTML, to JavaScript, or with JSON. Question?
Okay, that form 4 right there, does it know what method to use based on the controller action?
So it'll send it to the post routes, right? Now, form 4 assumes that you have defined in the controller, resources, right? Post, right? So it assumes that you have that. So you have your get and your update routes, as well as your create. And so if you do form 4 at post, if it's if the controller is, if this is the view that correlates to new, it'll send it to the create action. And if it's the view that correlates with get, to show essentially, it'll send it to update. So form 4 knows how to route it to the right action on the controller.
So if it's if we're on the edit page, this same form will go to the update.
Go to the update, exactly. So that's why a lot of times on a partial, you can declare a form 4 in the partial, and then just have that partial being used multiple places. And then it knows based off whatever view inherits the partial, where to send the action to. So it works both ways. It assumes though that you've defined it like this, so that your routes has something like this, right? If you do that, then the form 4 knows how to handle it smartly. So Ajax, remember we responded we responded initially, right, the first few weeks was responding all with HTML. And so that was just responding down with either a partial or a new view. And so we'd have to redirect us or route us to a certain action and send down a certain view. We also respond with JavaScript. So the JavaScript then executes when the server sends it down to the client. And so the JavaScript could just look for a certain div element and update it or change it. You also could respond with JSON, which is just a blob of JSON or JavaScript object notation data. And then the client then in this case has to know how to deal with the JSON. So the client has to then have some code that says, all right, when the JSON comes down, let's add the JSON in this way to the div, or let's look for a certain element. If the element exists, add in the JSON or something. Right? So the client then is responsible for actually using that data to update the view as needed. So great, that was week 4. Week 5, what did we cover? Exactly, WebSockets and action cable. So we talked about setting up the chat server. We have multiple people. You can send down a push request, right? So we had the terminology. Right, we have a connection, which is the actual layer that connects the server to the client. We had the channel, which is what you subscribe to. So you can subscribe to a channel and get notifications. We also had broadcasts. So you can broadcast a message from the server down to the clients. Let me see if I can. So we had example like a stream from, right? You would choose a topic to stream from. So maybe just simple as room, or maybe it's the room with an ID field on it. So that you're only going to get the messages down from that room. And then you could broadcast messages down to all the clients. And then the clients, again, have to, once they receive the message, they have to know how to update the view accordingly. It depends on what the message is, but we were sending down just the actual new message in JSON format, and the client would take that message and append it to the div. And so WebSockets is pretty powerful. We used it for the chat server and integrated it with Action Cable. Great. Week 6. Does anyone remember what we covered? Projects, yeah. We covered Heroku commands. So remember the database and Redis and Heroku deployment. So with the database, we talked about a little bit how Heroku sets up PostgreSQL database for us. Also how to configure a Redis database. We needed Redis in this case because we were using Action Cable. And in production, Action Cable uses Redis, whereas in development, it just uses the local web server. Does anyone remember why we can't just use the local web server in production for Action Cable? Right?
Are not exposed, I guess.
You could expose the port. So on development, we have the port. We have one port, and we use that to broadcast and receive messages. But in production, we could have multiple web servers, right? And so we need some resource to keep track of all the connections in the state. And so we need a centralized resource, and that is Redis. Redis basically is a way to configure all the different topics, all the different channels, and make sure that each person gets the message exactly once. When we're doing it just locally, we only have one web server, so it can do it itself. But in production, Heroku gives us the option to scale out dynos, so we can add in, multiple dynos of web servers. So we need one way to consolidate all that information. So that's why we had Redis. Redis is also very useful as we talked about, like a caching layer. as well as it's useful with the other thing we talked about, which was active job and sidekick. Right? So if you want some sort of background job processing system, most job queues are stored in Redis because it's fast. It's a good way to handle a lot of job processing. So Redis can be used for action cable and background job processing. In addition to other things like cache storage and stuff. So we kind of covered these two use cases, but there's a lot more. We also, let's see, so we also did some deployment. So, right, git push Heroku, and you want to do some branch. So your branch here, and you're pushing that to master. Right, so if you push to Heroku on a different branch, it's not going to do anything with it. It only looks at the master branch. So you make sure you push whatever branch you're using to master. But once we set up Redis, right, we went through the whole Heroku add-on process, finding a tier that worked for us, added in Redis. We had to configure it, so we had to add in the YAML file, add Redis to the cable.yaml file, right? And we also do use Heroku config. So the action cable file, right, cable.yaml. Huh? Someone's watching Netflix.